Welcome to Best Math and Science Videos, Factoring Using the Difference of Squares. The difference of squares means one squared term minus another squared term, a squared minus b squared. Factoring means writing it as a product of simpler expressions, a plus b times a minus b. Let's look at how this works. We can use the FOIL method. Multiply the first terms to get a squared. Multiply the outer terms to get minus ab. Multiply the inner terms to get plus ab. And multiply the last terms to get minus b squared. The middle terms cancel, and you are left with a squared minus b squared. This shows that if you have an expression of the form a squared minus b squared, then you can just write the answer as a plus b times a minus b. It's that simple. The trick is just identifying what a and b are. Let's look at some examples. To factor each of these expressions, identify a and b so that it has the form a squared minus b squared. Look at x squared minus 9. For the first term to have the form a squared, a must equal x. For the second term to have the form b squared, b must equal 3, because the square root of 9 is 3. So you can rewrite the expression as a plus b times a minus b. So x squared minus 9 becomes x plus 3 times x minus 3. And that's your answer. Now look at 81z squared minus 16. From the first term, you can see that a equals 9z, because the square root of 81z squared is 9z. From the second term, you can see that b equals 4, because the square root of 16 is 4. So the expression can be factored as 9z plus 4 times 9z minus 4. For 9m squared minus 100n squared, a equals 3m and b equals 10n. So the expression can be factored as 3m plus 10n times 3m minus 10n. And for 169h squared minus 625k squared, a equals 13h, because 13h squared is 169h squared. And b equals 25k, because 25k squared equals 625k squared. So the expression can be factored as 13h plus 25k times 13h minus 25k. Notice that it doesn't matter whether we have variables or numbers or a combination of them, as long as they have the form a squared minus b squared. These are all straightforward, but now let's look at some less obvious expressions. Again, to factor these, we first have to determine what a and b are. So, for p squared minus 1, you know that the square root of p squared is p. So a is p, and the square root of 1 is 1. So b is 1. So the factored form is p plus 1 times p minus 1. Now look at the next expression, 12x squared minus 75. 12 is not a perfect square, and 75 is not a perfect square. For an expression without perfect squares, think. Do the numbers have a common factor that you can factor out? In this case, yes. 12 is 3 times 4, and 75 is 3 times 25. So we can rewrite the expression by factoring out 3. Now look at what remains. Are these perfect squares? Yes. The square root of 4x squared is 2x, so a is 2x. And the square root of 25 is 5, so b is 5. And the factored expression is 3 times 2x plus 5 times 2x minus 5. Now look at 64x to the 6th minus 9y to the 4th. For this expression, a equals 8x cubed and b equals 3y squared. So the factored form is 8x cubed plus 3y squared times 8x cubed minus 3y squared. Here are some examples of other types of expressions you might run into. Look at the expression 19p cubed minus 4. Notice that 19p cubed is not a perfect square. If the term with variables is not a perfect square, the expression can't be factored using difference of squares. Now look at minus 36j squared plus 225k to the fourth. We need to rewrite this expression so that the positive term comes first. So it becomes 225k to the fourth minus 36j squared. The square root of 225 is 15. So a equals 15k squared and b equals 6j. So the expression becomes 15k squared plus 6j times 15k squared minus 6j. This next expression is a little different. How can you factor x minus 4 squared minus 81? The first part is a perfect square if you let a equals x minus 4. And the second part is a perfect square if b equals 9. So we rewrite the expression as x minus 4 plus 9 times x minus 4 minus 9. But don't forget to simplify. The expression then becomes x plus 5 times x minus 13. Here are a few more examples of things you need to watch for. How can you factor 9x squared minus 15? Notice in this case, 9x squared is a perfect square if a equals 3x, but 15 is not a perfect square. However, we can still use the difference of squares to factor the expression because only the numerical term is not a perfect square. So b equals the square root of 15. The factored expression then is 3x plus the square root of 15 times 3x minus the square root of 15. Now look at x to the fourth minus 81. In this case, a equals x squared and b equals 9. The factored expression is then x squared plus 9 times x squared minus 9. But look carefully at this expression. The first term is a sum of squares, so it can't be simplified any further. The second term, however, has the form of a difference of squares. We can factor this again. In this case, a equals x and b equals 3. So the final factored form is x squared plus 9 times x plus 3 times x minus 3. In this video, you've seen how to factor using the difference of squares. You might also be interested in these related videos. Factoring trinomials with a leading coefficient of 1, or with a leading coefficient not equal to 1, or perfect square trinomials, or by grouping. Links to these videos are in the description below. And be sure to click below to subscribe to Best Math and Science videos. Thanks for watching. See you next time.